Our video is about chi-square tests for two-way tables. There are two types, a test for homogeneity and a test for independence. They're basically the same thing, but homogeneity is when the data comes from two samples, and independence is when the data comes from one sample. Okay. The null hypothesis for a chi-square test of homogeneity is there is no difference in the distribution of the categorical variable for each of the populations or treatments. The null hypothesis for a chi-square test of independence is the two categorical variables are independent in the population of interest.
So for example, if you get a chi-square test problem with only one sample, you're going to want to use the four-step process, starting with state. And the null hypothesis would be that the two categorical variables are independent in the population of interest, and the alternative hypothesis would be that they are not independent in the population of interest. But you have to use these hypotheses with context, and that would change within every problem. And then your plan step would say that you are using a chi-square test for independence, and you have to check your conditions, which are that you either take a random sample or a randomized experiment is done, or the large counts condition is met where every expected count is greater than 5. So to check your expected counts condition and calculate the expected counts, the formula is row total times column total over the whole table total. So if you wanted to find this shaded expected count, it would be x times y over z.
So if you're using a TI 83 or 84, you're going to enter the observed counts in matrix A. You're going to press second and x to the -1 matrix, arrow to edit, and then choose A for matrix A. You're going to enter the dimensions of the matrix, the 3x3 matrix, and it'll come up like this. Enter the observed counts from the two-way table in the matrix, and then specify the chi-square test, the matrix where the observed counts are found, and the matrix where the expected counts are found. Okay, after you enter your data for matrix A, matrix B will automatically provide you with the expected counts, and that way you can check to see if your large counts condition is satisfied.
To get full points on the do section, you need degrees of freedom, a test statistic, and a p-value. To find the degrees of freedom, you need to multiply the amount of rows minus 1 times the amount of columns minus 1. For your test statistic, you can either use the equation observed minus expected squared over expected, or calculate it with your calculator. To find the p-value, you can use table C, or also use your calculator.
To do the do portion of the chi-square test, you're going to press stat on your TI 84 or TI 83 and choose chi-square test. Adjust your settings, so observed matrix is going to be in part A, expected is going to be B, and then you're going to calculate.
For the conclusion, you need three things: comparison of the p-value to the significance level, fail to reject the null hypothesis, and context. For example, you would say something like, because p is less than the significance value, we reject the null hypothesis. An example problem from a released AP exam that deals with chi-square test for two-way tables is on the exam for 2013, and it's question 4.